Hello everyone, let's start the new topic from the unit of spur gear, that is friction between gear teeth. In this lecture we are going to discuss about the condition for minimum frictional loss. So let's start with the construction of figure. So here we have gear 1 with center O1 and gear 2 with center O2 having angular velocity omega 2 and here is the omega 1. This red circle represents pitch circle of gear 1 and 2. Let me draw the base circle for gear 1 and 2. Now let's draw a common normal passing from the pitch point. So here is our pitch point P. Here is the normal drawn from the center to the common normal. We give the name as A and N. Let's draw the common tangent passing from the pitch point. So here is the tangential force Ft. And angle between common normal and common tangent is pressure angle phi. Now let me extend this construction. So here again we are going to plot perpendicular to the, let's say this is also a tangential line which cut pitch circle of gear 2 at point, let us say S. Give the name for this point B and join S to center, that is O2. Let us consider this angle AO2B is theta 2 and we know that angle AO2P is phi. And R2 is the pitch circle radius of gear 2 and R1 is the pitch circle radius of gear 1. So here we finish with the construction part. Now Fn is the normal force acting at point of contact. So in the direction of normal force is acted by from driver to the driven. Then we know that Fn is equal to Ft divided by cos of phi. Then phi is the pressure angle, omega 1 and omega 2 is the angular velocity of gear 1 and 2 respectively, Vs is the sliding velocity in mm per second and mu is the coefficient of friction. Now see this triangle O2AP and O2BS carefully. O2AP and O2BS. Now in this triangle, see O2A and O2B is the radius of base circle. So both are the equal. So O2A is equal to O2B. Then O2S and O2P are the radius of pitch circle. Again both are equal, so O2S is equal to O2P. Again see this triangle O2AP, that is 90 degree. Similarly O2BS is also 90 degree. So angle O2AP is equal to angle O2BS equal to 90 degree. It means both are the similar triangle. So O2AP and O2BS are the similar triangle or congruent triangle. So that we can say that AP is equal to BS. So let me write it. AP is equal to BS. Now let's add one more construction part. So here I have drawn the addendum circle for this gear 2 and just generate an arbitrary tooth profile, okay, which is cut, or addendum circle cut the common normal at this point. So give the name for that point is, let us say, R, and to this point E. Now see this AR carefully. AR is the tangent to this base circle. Now as we know, in involute tooth profile we just unwound the string from the base circle. So when we unwound the string from the base circle, we generate this tooth profile by unwounding this AR, which is tangential to the base circle. It means what? Length AR is equal to arc AE. And similarly, see the BS, we can write here BS is equal to arc BE, because in involute we generate the tooth profile by unwounding the string around the base circle. Okay, so in this case we just unwound this much arc and it will be tangential to the base circle. So length AR become arc AE. Similarly, length BS is arc BE. So arc AE minus of arc BE is equal to AR minus of BS. So arc AE minus of arc BE, it become arc AB. Arc AB is remains. So AR minus of BS. Now see, AR minus of BS. BS is nothing but AP. So we'll just put AR minus of AP. So arc AB is equal to AR minus of AP. So what remains is just this, that is PR. So we can write that arc AB is equal to PR is equal to path of recess. Now let's calculate sliding velocity at recess. So sliding velocity recess is equal to omega 1 plus omega 2 into distance from pitch point. So that is nothing but PR. Okay. And when we are going to calculate average sliding velocity at recess, so what is that? It is addition of this. At pitch point the velocity is 0 and at R the velocity is this, that is omega 1 plus omega 2 into PR. So average sliding velocity is just omega 1 plus omega 2 into PR. Instead of PR now we'll put arc AB. So it's arc AB by 2. So again we are going to simplify this, omega 1 upon omega 2, omega 1 plus omega 2 into, instead of arc AB, see arc AB is this, so we can write O to A in terms of angle and length, O to A into this angle theta 2. We are going to consider this angle theta 2, that angle OA O to B. So arc AB is O to A into theta 2 by 2. Now again, instead of this O to A, see this figure carefully, and angle AO to P. Angle AO to P. In this angle AO to P is phi. Okay, so we can write, instead of O to A, we write in terms of pitch circle radius of pinion of gear 2. Okay, so it is O to P into cos of phi. So let's write it. instead of O to A, we'll just write O to P into cos of phi into theta 2 as it is divided by 2. So it becomes omega 1 plus omega 2. O to P is nothing but R2, pitch circle radius of O to P. It is pitch circle radius of gear 2 or pinion. So instead of that, we'll write R2 cos of phi into theta 2 divided by 2. Now let's find out frictional work done during recess. We know that work done is equal to, let me write over here, work done is equal to power into time. And we already know that power is in terms of force into velocity into time. So when we are going to calculate frictional work done during recess, we'll take into this way. So force into velocity into time. Now force is the normal force, that is Fn. Okay, we know that Fn is Ft upon cos of phi, but this is the frictional work done, so we'll put mu into Ft upon cos of phi into average velocity at recess into time. Okay, so let's mu Ft divided by cos of phi into, let's put this average velocity, we have already calculated it in terms of formula, so it is R2 cos of phi theta 2 divided by 2 into time. Now let's write the time in terms of displacement and angular velocity. This is the angular displacement and angular velocity, theta 2 divided by omega 2. So now they see this cos phi and cos phi get cancelled. So let's write the simplified term. Here we have the omega 2 in dividation, so let's divide by this omega 2 into this bracket. So it becomes 1 plus omega 1 upon omega 2. This omega 2 get cancelled and it is omega 1 upon omega 2. R2 as it is, theta 2 become theta 2 square divided by 2 as it is. So let's write this mu Ft by 2 1 plus omega 1 upon omega 2 into R2 theta 2 square. This is frictional work done during recess. Similarly, we can able to calculate frictional work done during approach. So it is equal to mu Ft by 2. So mu Ft by 2 remains as it is, 1 plus, now here is the omega 1 upon omega 2, we calculate this in opposite side, so it become omega 2 upon omega 1, and here is the R2 theta 2, because we are considering this gear, here is the R2 and angle theta 2, so when we consider the another gear to calculate frictional work done for approach, it become R1 theta 1 square. Let us say this is equation 2 and this is equation 1. Now when we want the total work done, it is addition of frictional work done during the recess and frictional work done during the approach. So let's add equation 1 and equation 2. So it becomes mu Ft by 2 1 plus omega 1 upon omega 2 into R2 theta 2 square plus mu Ft by 2 1 plus omega 2 upon omega 1 R1 theta 1 square. Now see, these two terms are same, so let's take that common, mu Ft by 2 into bracket. So what remains is 1 plus omega 1 upon omega 2 r2 theta 2 square plus 1 plus omega 2 upon omega 1 r1 theta 1 square, bracket close. Now instead of this omega 1 and omega 2, we can put r1 and r2 by using of gear ratio. So we know that gear ratio G is equal to, let's say, in terms of omega it is omega 1 upon omega 2, but in terms of r it is reverse, r2 upon r1. Okay, so we can put the value of r instead of omega, so it become r instead of omega 1 we'll put r2, instead of omega 2 it is r1, multiply with r2 theta 2 square plus again here 1 plus omega 2 we'll put r1, omega 1 it is r2, r1 theta 1 square. Okay, so next is we are going to multiply by this r2 in right side for more simplification. So mu ft by 2, so into bracket it become r2 plus r1 divided by r2, r1 theta 1 square plus again let's just simplify this term, so it become r1 plus r2 divided by r1, r2 theta 2 square. Again let's simplify this. Now divide and multiply this term by r1, so it become r1 plus r2 divided by r1 into r2, and multiplication it goes right here, r1 square theta 1 square plus similarly divide and multiply this term by r2, so it become r1 plus r2 divided by r1 r2 into r2 square theta 2 square, bracket close. Then see this term is common, so we'll take that common, mu ft by 2, just take this term common, r1 plus r2 divided by r1 r2 into bracket r1 square theta 1 square plus r2 square theta 2 square, bracket close. But we know that, see, in this triangle if we are considering the r2 and theta 2, what it is become path of approach, that is AP, and r1 theta 1 become path of recess. So r2 theta 2 is path of approach, r1 theta 1 is path of recess. Let's consider path of approach is L1, path of recess is L2, and L is the path of contact. L is equal to approach plus recess. And let us consider this whole term constant K. So K is equal to mu ft by 2 r1 plus r2 divided by r1 into r2. Why we are considering this term constant? Because when we take 2 gears, this r1 and r2 never change. Similarly, the force and friction, which is depend on the material. So we can write work done is equal to, so instead of this term now we put k into bracket, now r1 theta 1 bracket square, so r1 theta 1 is L2, so L2 square plus r2 theta 2 bracket square, it is L1 square. So K L1 square, now instead of L2 we'll put L minus of L1 bracket square and then close this bracket. So here we have total frictional work done K into bracket L1 square plus L minus of L1 square. Now for maximum work done and minimum frictional work, what we are going to do, we are going to differentiate this work done with respect to L1 and equate it with 0. So let's differentiate this work done with respect to L1 and going to equate with 0. So K d by dl into bracket L1 square plus L minus of L1 bracket square bracket close equal to 0. So it is K to differentiation of this is 2L plus 2L minus of L1 into minus 1 bracket close is equal to 0. So K into bracket 2L1, let's multiply by this 2 inside the bracket, also multiply with minus 1, minus of 2L, and this minus minus become plus 2L1 is equal to 0. Let's take 2 common. Let's take 2 common and let's shift this term on another side. So what we get, 2L1 minus of L is equal to 0. So we'll get L is equal to 2L1, or we can say that L1 is equal to L by 2. This is the very important condition, or we can say that this is the condition for minimum frictional work loss and maximum work done. So what we can say according to this, length of approach must be half of total length of path of contact.